We're into the final set of talks now, and we have 4 talks. And these are all what are labeled as Keston Award talks. These are essentially, for those of you who don't know, these are essentially proposals that people put together a year ago to do a project that was funded by the Keston Endowment. I would like to acknowledge both Linda and Daniel Keston, who are sitting in the back over there, who have come today. And I think that these are some pretty exciting work that people proposed. Last year we had 21 proposals. We selected 5. 4 of them ended up proceeding forward, and we're going to have 4 talks today. And so the first talk is given by Hengameh Mirzaalian, and she's a computer scientist in the AI division. And the talk is on identification of congenital adrenal hyperplasia using convolutional neural networks.
Hi everyone, it is my great pleasure to make this presentation here at ISI Research Day. I am presenting this work on behalf of my collaborators, Dr. Wael Abdulmajid Zhao Gao, Dr. Leo Espinolas, and our wonderful collaborator from Children's Hospital of Los Angeles, Dr. Mimi Kim. I will start with a short introduction on the disease we are studying on this project, congenital adrenal hyperplasia. CAH, or congenital adrenal hyperplasia, is the most common primary adrenal insufficiency in children. And as some of you might know, adrenal glands are located on top of our kidneys. Sorry, my voice is okay? Okay, perfect. Adrenal glands produces important hormones in our body, and these hormones play important roles like balancing blood pressure, balancing level of sugar, salt, stress in our body. And people who are affected with CAH, what is happening in their body, their hormones will become imbalanced. And these imbalanced hormones in their body causes different physical and mental issues for them, like depression, diabetes, kidneys problems, heart problems. And what we are addressing on this project is we are trying to find the answer to this question. Does CAH have recognizable facial features? And in that, this is not a random question. There is a logic behind this question. We know that CAH affects level of testosterone in the body of the patients starting from week 7 of their fetal life. There are studies which prove that level of testosterone affect development of sexually dimorphic facial features. So there might be a good chance that, there's a delay here. So there might be a good chance that CAH also makes some effects on the development of facial features on those patients. Sorry. And if we find the answer to this question, it will help to understand time-specific contribution of hormone imbalance to the development of the disease, and eventually it helps to understand changes to the brain structure and changes to the patient behavior, and finding the answer to these questions are very important and critical. Now let's check out some existing works. There are many works done on facial analysis, but they are having different applications. There is no work on CAH facial analysis, and our group is the first one who is studying this issue. For example, there are works on gender analysis using face images. What they do is that they start by detecting some anatomical landmarks on the faces, and by anatomical landmarks, we mean, for example, corner of the eyes, corner of the lips. And then they design some features, like ratio of height to width of the faces. And they show that, oh, for female and male, these features, these ratios are different. But these techniques are ad hoc, and there is no guarantee that those handcrafted features are the optimal features. But why not applying more sophisticated artificial intelligence-based techniques like deep neural networks? Deep neural networks are designed to discover those optimal features for us. They train themselves to capture those best information. And here on this slide, you can see our pipeline for CAH analysis. For people who are interested to know technical details of our pipeline, we are using VGG 16 up to layer FC6, and then pass them to a small neural network which is having few layers of fully connected. And one thing that I want to highlight is that why is our problem is much harder comparing some other existing techniques which are also using deep neural network for some other face analysis. There is a well-known software called Face2Gene, and here I will show some of their data, some of the images in their data set. I believe that most of you agree that it's easy to quickly capture by our eyes something is wrong with these faces. Their facial morphology is far away from facial morphology of control kids. And here, I will show you sample of images in our data set. If I ask you label them for me, which of them is control, which of them is affected with CAH, I think that it's not easy. Even if I show you the two groups and ask you to label them, I think that is challenging. And all I am trying to say by this slide is that the images that we are working with, they are much more challenging compared to the images used by other groups like Face2Gene. Okay, here you can see some statistics of our current data set. Children's Hospital provides us sample of images of kids affected with CAH, sample of images of kids which are control. We use these images and pass them to our network, train our network, and our evaluation results indicate that our model is doing a good job to differentiate these two groups. And in terms of AUC, we ended up with 0.83 value, which is a reasonably good classification result. So back to the question we asked in the beginning, does CAH have recognizable facial feature? Our answer is yes. It does have recognizable feature. And we not only could able to differentiate these two groups, we can explain the difference of these two facial morphology using, sorry, there is a delay here, class activation maps. And these class activation maps show for each of these two groups which regions are more informative. So far, we were able to make some publications out of this work, and it seems that this topic is attractive for people in genetic and endocrinology community, because, again, we are the first who are making this question and show that, yes, it is possible. And back to our data set, you might ask why our data set is small. The reason is that physicians drag kids to some camera room, which are located in plastic surgery clinics, and there are 3D laser scanners on these clinics. And these laser scanners are super expensive, $68,000. And of course, finding some free spots available on those scanners is challenging. Now, the question is there a cheaper and easier way to collect the data? To answer this, we design and build an imaging system in our team, which is portable and cheap. This is the $300 camera that is built in our team. It has illumination unit to control the illumination data. It has 3D camera, and it has control unit to synchronize the illumination with the collected data. And our goal is to use this local portable camera to pediatric clinics, collect more data. And we want to make more units of these, send them to more hospitals across the country. And we want to build the consortium to collect more data to carefully study the CAH disease. And at the end, I want to thank Keystone family for their kind support. Without their support, it was impossible for us to do this study so far. And thanks to everybody here listening to our presentation.
The image data, a fantastic presentation and really phenomenal work. Did you talk to any physicians? I mean, are they using, when they're looking at a patient, were they able to provide you any additional information, like they can look at a patient and see issues and then that could help you, or did you provide that information back, like the heat plot that you had? Was that useful to them?
Yeah, excellent question. Actually, our collaborator, which is an expert in this field, she's the one that she has lots of patients in this problem. And after checking these too many patients, I think she trained herself and she noticed that, I can, without checking their blood test information, I can tell you which one is affected with CAH and which one is not. But it was not easy for her to explain what are those exact features. But she said, maybe I think their eyes is downward rotated. So they provide us this kind of information. And then, but again, it was not easy to measure with some handcrafted features. What are those features? And she provided us this data set. That time was the time that it made this ignite on our team that, okay, let's do something on these images and see, can we capture this facial morphology between these two groups? And the interesting thing is that there is a logic behind these changes on the facial morphology, because it affects adrenal gland, then adrenal gland change testosterone level in the body. And in this community, people know that testosterone level will make some changes on the facial morphology. And of course, finding the answer to this question is very important for them, because then they can have a more accurate study on the patient behavior, on their changes appears on their brain structure. And there are studies which prove that the brain structure of these two groups are different. For example, hippocampus size, brain size, gray matter, white matter are different between these two groups. But nobody shows that facial morphology is also different. And now it seems that there is a connection between things inside the brain and outside the brain. And these are the future directions that we are trying to make this connection between these kind of things. I am hoping that I answered your question.